Hello, this is the second part of our dimensional analysis notes for solving multiple dimension squared problems and cubic problems. Alright, so the rules are still the same. Remember, you write all measurements as a fraction. Now, it might not seem like you understand why we do that, but when we get into stoichiometry and more advanced problems, this will definitely save you because you know that number is supposed to be in the numerator, not the denominator. Anyways, so we write all numbers or measurements as a fraction. That means put it over 1. Make sure everything has a unit. Make sure your conversion factors cancel out the units. Make sure anything on top is multiplied, things on the bottom are divided, and your significant figures in your answer are the same as what the starting number was. Here is our metric prefixes. Okay, I went over this in class. Just remember that kilo means 1,000 or 10 to the third. Remember, this will help you. Oh, that looks awful. This will help you when we start getting into some bigger numbers, and this is the multiplying factor, what each prefix means. Okay, you should have this in your notes. Let's talk about what is the key. How do you solve dimensional analysis problems? So the key is to solve one dimension at a time. Okay? Alright, we're going to solve one dimension or unit at a time. Now, when you're copying down these notes, or if you get lost or you can't remember or you're trying to figure out what I did, what's nice about this is just hit pause, go back, and just looking again and re-listen to what I said and check your notes. Okay, so that means we're going to solve the top first. Okay, that means we're going to solve, oops, that's an I. Solve the top first and then the bottom unit last. Okay, so let's go ahead and let's jump into it and let's solve one of our problems, or this first problem example. Let's convert 17.2, now this is miles per hour to meters per second. I'm going to rewrite this as miles per hour, or HR, doesn't really matter. Okay, now we're going from miles per hour to meters per second. So what I'm doing is I'm making the top unit, I'm converting miles to meters and hours to seconds. Alright, so this is how this unit is actually written out. It's 17.2 miles per 1 hour, or H. Okay? So now, let's go back and let's try to figure out how can I solve or make miles into meters. Let's see, no, not that one. Let's go back this way. Here we go. Okay, so these are the two things I have with miles. I can convert feet or miles to feet, and let's see, then feet to centimeters, and centimeters to meters, or I can convert miles to kilometers, and then take a look right here, kilometers to meters. So I'm going to do that one. This is the path I'm going to take. I think that's a little bit easier to do. Okay, so let's go ahead and let's do that. So I'm going to convert miles to meters. So I'm going to put, miles to kilometers first. So if miles is on top, I put miles on the bottom, and in 1 mile there's 1.609 kilometers, or kilometers if you want to sound sophisticated. I just say kilometers. Okay, now I don't want kilometers or kilometers, I want meters. So I know that in 1 km, that's a horrible looking K. Oh my gosh, what's wrong with me today? I think that I just made it worse. That's alright. There are oh boy, here I go again. 1,000 meters. So that cancels out. And now what I'm going to do is I'm just going to circle this unit because that's the unit I want to achieve on top, and I got it. Okay? So I'm good on the top part. Now I just got to worry about the bottom part. So I have to convert this hours right here to seconds. Okay? So we just start doing the same thing. Now, from up to this point, we said all of our conversion factors have been right next to each other, but that's okay. As long as the conversion factor is somewhere in the problem, it doesn't matter how far down it is or if it's right next to it, it'll all work out in the end when you multiply and divide. So if I have hours on the bottom, I'm going to put a little HR so I don't get confused. Alright, so if I have hours on the bottom right here, that means hours has to go on top. And I got to start converting this to seconds, but I know in 1 hour, there's 60 minutes. Okay, So my hour over here cancels all the way over here. Remember, this is in the denominator, now it's in the numerator, so it does cancel out. I don't want meter per minute, I want meter per second. So I have one more to do. And I know if minutes is down here, I put 1 minute on top, and there's 60 seconds. Or is it just S? That's alright. 60 seconds in a minute, and that cancels out. Now I'm left with the unit I want right here. Okay, in the denominator, meter per second. The fraction means per. Okay, so how do I solve this? Well, I plug in 17.2 in my calculadora or calculator, and I just move right on down the conversion factor, right on down the road, and just if it's something on top, multiply, something on the bottom, I divide. I look at 1.609, it's on top, so I multiply. I move on down to the next conversion factor. It's thousands on top, so I multiply. Move on down, 60's on the bottom, so I divide. And go to the next one, 60's on the bottom again, and I divide by 60 one more time. Alright, and I need 3 significant figures since there's 3 in my starting number, and I get the answer of, drum roll please, 7.69 meters per second. And that is my answer for the first example. Okay? That wasn't that bad. It's just a little bit time consuming, very tedious, but it's definitely doable as long as you just make sure your units cancel out. You're golden. Alright, let's take a look at our second example. So I have the density of gold, which is 19.3 grams per milliliter. I want to turn that to pounds per liter. So I start off by, I like IU colors, pick crimson. We have 19.3 grams per 1 milliliter. I want to get grams to go away. And from our notes from yesterday or earlier, we know that there's 454 grams in a pound. Let's go take a look just to refresh our memory. Right here, 454 grams in 1 pound. Okay, so I'm going to put the 454 grams in 1 pound on top. Grams cancel out, and I'm left with pounds, the unit I want in the numerator. So I'm good with this one. Now, I got to convert milliliters to liters. So let's go back and say, okay, where's the liter? Here we go. All right, in 1 liter, there's 1,000 milliliters. So if milliliters is on the bottom here, I'm going to put the 1,000 milliliters on top and 1 liter on the bottom. That cancels out, and I'm left with liters on the bottom. Okay, now since I got my units, I have to do the math part. Plug in that in my calculator, 19.3. Move on down. 454 is on the bottom, so I divide by 454. And with the next one, in 1,000's on top, so I multiply by 1,000. Alright, and I get my answer of 42.5 pounds per liter. Okay? That's a lot of weight. So if you had a 2-liter pop full of, or a 2-liter pop bottle full of gold, that actually would be about, about 86, 85 pounds. That's pretty heavy, I must say. Alright, take a look at our next example. Okay. Ooh, these are fun. Alright, I'm going from 44 centimeters cubed to inches cubed. Well, what is a centimeter cubed? That is the volume of a square or a cube or a square rectangle thing. And that is a centimeter times a centimeter times a centimeter. And we just want to convert that from centimeters to inch, and inch. Okay, so when we do these problems, this goes for squared and cubic problems, what you're going to do is you're going to rewrite this as a centimeter, centimeter, centimeter. Okay? Rewrite that as that so we can cancel out the units one at a time. So let's go ahead and let's start this. So we have 44 centimeters, centimeter, centimeter. Place that over 1. Now, what I have to do is figure out, well, how does a centimeter equal an inch? Well, I know that in 1 inch, that is 2.54 centimeters. Okay? So I'm going to rearrange my conversion factor, or this equivalence, to make my conversion factor. So if I got some centimeters on top, that means I'm going to put some on the bottom. So I have 1 inch on the top, 2.54 centimeters. Now, this cancels out 1 centimeter. So what this means, I have to do this whole thing 2 more times, or a total of 3, to get my centimeters to cancel out. So I'm going to do it a couple more times. So in 1 inch, there's 2.54 centimeters. So that cancels out a second one. And I'd have to do this one more time. So in 1 inch, there's 2.54 centimeters. That cancels out the third one. And if you did this correctly, you should have an inch times an inch times an inch right here. And all the centimeters should be canceled out. And then I'm in the units of inches cubed. So I take 44. Remember, how do you do this? You always start with that number first in your calculator. And then you move on down. Since all these 2.54s are on the bottom, I'm going to divide them 3 times. So I take 44 divided by 2.54 divided by 2.54 again, and divided by 2.54 for a third time, and I get my answer of, let's see, and I need 2 significant figures. When I type that in, I get 2.7 inches cubed. Alright, that's my answer for that one. Okay, got one more problem. Why aren't you clicking? There we go. Got one more problem to solve. Alright, let's go from 4.5 pounds per cubic foot, or is it cubic feet? I'm not exactly sure. 2 grams per cubic centimeter. Alright, so let's go ahead and let's start this. So we have 4.5 pounds per 1 cubic foot. Cubic feet. I guess it'd be feet. And I got to get that to go away. So let's start with our first unit. So I want to get from pounds to grams in the top. So let's convert that out. So I know that there are 454 grams in 1 pound. And let's see, that cancels out. So I'm left with grams. So I'm done with the top. Now let's worry about the bottom. Alright, so let's go back to our conversion factors. I don't want to have to convert inches or feet to inch and inch to centimeter. I was nice to you guys. I gave you this right here. Okay? There are 30.48 centimeters in a foot. So all I have to do is, just like this conversion, just like this, I do that 3 times on this right here. So let's go ahead and let's do that. Why am I using multicolors? Oh, that's okay. It's festive. So if I have feet on the bottom, I'm going to put in 1 foot on top. There's 30.48 centimeters. Okay, so that, we got expando. This is called expando version. Foot, foot, foot. Remember, I write that 3 times, so I see that cancels, cancel. Okay, and let's do it one more time. In 1 foot, 30.48 centimeters. Cancel, cancel. See what's nice about expanding that unit out right here, writing it out, because it's foot times a foot times a foot, and that's just a shorthand. It's easy to see when they cancel out. And I do this one more time. So 1 foot, 30.48 centimeters, and that cancels out a third foot. And I got centimeter, centimeter, centimeter on the bottom. That's what I wanted. I got gram on top, and I'm golden. I just gotta do the math now. Okay, so let's go ahead and let's start this. I take 4.5, plug that in my calculator. Okay, and I move on down the conversion factors, or right on down the line, and 454 is on top, so I multiply that by 454, and I go on down. 30.48 is on the bottom, so I divide that by 30.48. 30.48 is on the bottom again, so I divide it by 30.48, and it's on the bottom again, and I divide one more time by 30.48, and I get my answer. And to 2 significant figures, I get 0.072 grams per cubic centimeter. Okay, and that's it for the multiple conversion factors in cubic and square problems. We're going to practice a little bit more in class. Make sure you get this. If you have any questions, please let me or Mr. Kleinschmidt know. Thank you for watching.